Okay, go ahead. 6 more than 10 seconds.
Will we have a retake and also talk about dailies?
Yeah, you can. I don't know the one. All right. I'd like to consider. Let's start our discussion by considering the following example. We're thinking about inequalities eventually today is what we'd like to think about in one variable. But let's start with the following question with this polynomial that maybe you already could think about already. With the quiz we just did, maybe you already can think about how the graph looks even for this. So the first question, what real values make this function 0? That's a question. Let's start with that one and forget the others for now that we've been asking. When is f of x equal to 0? When does that happen? Go. Anyone. Shout them out. It should be -3. 4. Anything else? Yeah, no other real values. Yeah, but definitely you're right. I and -I. True. But we're going to only list the real ones. Okay, cool. Let's actually skip to undefined. Is there ever a time when f of x is undefined? Is the question. Keep in mind that this is a polynomial. Is there any x value? The question is there any x value that you can't plug in? Is there any x value that you can't input into this function and ask for an output? And the answer is no. There are none. All right. What about values when f of x is positive? We'll work on that in a minute. And when f of x is negative, let's think about those now in a little more sophisticated way, because this is maybe a little harder to see. The first two answers should be kind of prerequisite. I have it in its factored form. You're welcome. And so you can see what the zeros are. And it's a polynomial, and so of course it's not undefined ever, right? It's defined for all reals. The domain of any polynomial is all real numbers. Okay. So these last two questions are a little trickier. So let's bring in the aid of a picture. And I'm gonna actually think about plotting this. And I'm only gonna need the x-axis for this picture. Okay. If you want to put a y-axis there, you can. But I don't need it because I actually don't care about all the features on this graph. And it's kind of like that quiz question, though, right? I want to think about the general behavior of this graph, but I actually don't care about anything in terms of y, except whether y is positive or negative. That's all I care about. Okay. Like I don't care what the y-intercept is. I don't care where any maxes or mins might be. All I care is when is this above and when is this below the x-axis, and that's all I'm going to record as I go across. Now, a polynomial has a chance to change from being above to below, or from below to above, at what kind of place? At the zeros, right? Like that's its opportunity to cross over from the bottom to the top, right? So I'm going to make a little number line, and the only points I care about are -3 and 4, the ones we've already identified, okay? And now you've just said it. That's the only chance for it to change sign, is at those two places. So if you test a value over here, and it's positive, that means it must be always positive on the interval -∞ to -3, right? That's what this says. Either it's all positive there, or it's all negative, right? But it's not like it can be positive and then negative or something over here inside the interval -∞ to -3. It's either all one or all the others. Likewise with -3 to 4. It's either all positive in there or it's all negative. And also likewise with 4 to infinity. So actually, let's answer the question. From -∞ to -3, is it positive or negative? Maybe we actually plug in a value, like -5 or something, right? If you do, you get something negative here times something positive times something negative squared. So what will that come out to be? A negative times a positive would be a negative, yeah. Okay. By the way, this kind of analysis should feel familiar. When we were graphing rational functions the other day, do you remember I was kind of being crude and quick? I was like, is this going to be positive or negative? It was the same conversation, wasn't it? I was like, I actually don't care about the y value. I just want to know, is this branch of the function above or below the x-axis? I was just kind of being crude to get the overall picture, wasn't I? You remember that kind of loose, fast discussion? That's kind of what I'm doing here, too. I don't actually care what the y values are. I just want to know, are they negative? Yeah, okay, good. Let's keep moving. In here, plug in what? What's your favorite number in that interval?
-8.
2. No, it has to be in between -3 and 4. How is 0? Is my favorite number. Yeah, let's go for the low-hanging fruit. Let's plug in 0. If you do, you get positive times a positive times a negative squared. Okay, well, that'll be positive. So in the end, it'll be positive. And then what about over beyond 4? Like if you plug in a million or something. It'll be positive, positive, and then positive squared. Yeah, you'll get something positive, okay? How do you like that? So far, so good? By the way, like I said, let's make sure we're making connections between this picture and the picture of the actual graph. What we're saying is the graph is below the actual y value, the actual graph itself, if we were to plot it, is below the x-axis, and then it's above, and then it's above again. Does that reckon with what we know already about like multiplicity and all that?
Yeah.
All right, so we can test values, or you might be able to kind of think about actually how would it look if you plotted it. Yeah, it'd be negative, and then positive again. That makes sense. So let's write these down. From -3 to 4, we want to write. It's positive, and also from 4 to infinity. And it's negative from -infinity to -3. Okay, and by this cut symbol, that's a union sign. It means x can be in this interval or in this interval. Yeah, no, we don't want to say 4 because 4 is not greater than 0. I mean, 0 is not greater than 0. Because at 4, it's not. If you plug in 4, you get 0, which is not strictly greater than 0. So, right. All right, try another one while you're in the mood. Go. Draw a little number line. You're gonna be like that? You're gonna be like,
No, it's just a real question.
don't worry, you know how I roll. It'll get more interesting, I promise. I know I'm boring you now. I'm sorry, man.
Don't be I need more
Of course it's,
What are we putting on a number line? -4
of course it's -4.
and 3. Is that it?
Well, it's not the same number.
Similar. And then test some values.
There's a multiplicity.
Yeah, you can use the multiplicity argument to come up with these. You don't have to necessarily plug values in if you know everything you know about polynomials. Think about its end behavior. Whatever you need to.
We have, do we have to do the 0 and the undefined? Okay, no undefined.
I don't know. We'll see what people say. Check with your friends.
You guys get negative. What?
What's the first one? If you plug in -5,000 or something, you get something positive?
Yes, I got
Okay. If you plug in something like 0 again, negative? Okay.
And negative.
And then over here, negative? Do you guys agree on those answers? All right. So we'll just go with that. I'm not going to write it actually. But now I want to ask this question, because this is actually more in line with the kind of question I'd like to be able to ask today. I think the analysis we've just been kind of building up, though, has been helpful. All right, so now I'd like to ask this very, very suspiciously similar question. Okay, solve the following inequality. Well, actually, the question we've just asked is harder than this, right? When is this expression, what t values will make this expression greater than 0?
-4 or 3.
Yeah, it's these values over here. We could even go back algebra 1 style, shade our number line, you know, like open circle there, you know. So we can actually write down the answer. It's negative infinity to negative 4 exclusive, right? T is any number in that interval, and if it is, then this inequality is satisfied. If it's not, then this inequality is not satisfied. Is that okay? Yes, Lisa? Oh, that means T is in the interval. T is in the interval. It means is a member of, or
That looks like the Euros.
T is in that interval. Is a member of the set, whatever you want to say.
What looks like the euro sign? Oh, that.
Okay.
It does. Don't tell
I
me.
can tell though, Matt's still hungry for more, aren't you? Yes, you want more. Bring it on, he says. All right, well, let's do it.
There you go.
Let's go. All right, so let's solve this one. Notice all the ones I've given you so far have been, you know, nice, tidy, factored. I want to know what. Give me a set of all x values, please, that makes this statement true.
Oh, we're supposed to solve that. I don't like solving that. See how it is. Why did I do that?
Alright. What? Like,
You're right.
x cubed plus x.
How do we choose? Oh, one of the x equals
What are you, people out there, what are you doing right now? Someone tell me.
I'm factoring.
Factoring.
Before you did that, you maybe
GCF. Yeah, move the 8 over.
move the 8x over. All right.
So x
X.
0, 4, 2.
Where? Yeah. Oh yeah, that works.
Total.
No. So x equals 0.2. That doesn't answer your question.
Yeah, well it does because then you can do
When is it greater than or equal to?
Got it. Already got it.
How do you do this out?
Wait, so do we just write it like we did last time with the t, blah blah blah?
Yeah. All right. So let's. How are you doing on this? I mean, you might even know it's a cubic, right? Let's just go. Let's go quick and fast on this one, right? It's a cubic, right? It looks like this. End behavior like this. Boom, boom, boom. I think it's negative. Positive. Negative.
0 to 2.
Positive. Yes? Right? I mean, I'm just going by my picture that I think I know about it. That's what I think. Does that work? Or you can plug it in too. If you plug in -5, for instance, you get a negative times a negative times a negative. That's a negative. Cool. Or if you plug in 1, you get a positive times a negative times a negative. That's a positive. So one way or another, can you get these answers so far? And then what's our final answers? We're asking for when is this
It's
greater
X.
than or equal to 0?
It's x and then the weird euro sign.
All right, so here we want to include closed circle algebra 1 style, right? Closed circle.
I got it.
All right, so how do we write that? Yeah, maybe x is in the set, the closed interval, 0 to 2,
And then
together with
union 4 to
4 to infinity.
4 to infinity and 1.
How do you like that? Is that good? Pick a number in this set, and you'll have a true inequality. Pick a number not in those sets, and you will make that statement false. All right, with that in mind, oh shoot, I think this is going to come up underneath of it. That's a little sad. All right. What if the roots were messy? It says, sorry, just like this PowerPoint. Could you do this without with a calculator? You know?
But you could do it without.
On this particular example, you do not need a calculator. Let me also mention, by the way, that if this was terrible to factor, that would also be okay, right? Maybe like we could give you a problem like that. Wouldn't that be fun? You have to like do an inequality, and in the process also maybe think about rational root theorem, or like have to search for the root.
Depending if it was x squared. If it was x squared, you could just do that.
Yeah. If we needed the quadratic formula, that would be okay too here. All right, hey guys. So the point is, even if the roots are messy, if you have a calculator, I think I'm trying to think if there's a homework problem like this tonight, maybe. You might just have to draw a picture on the calculator and be like, okay, yeah, it's going to be positive from whatever this messy value is to whatever this messy value is. And it's going to be positive from whatever this messy root is over to infinity, right? And you could do that with approximations and stuff on the calculator too. I'm not really going to go into that, but like you understand how you might if it was a terrible function. You could look at a picture and solve the inequality using the picture. Yeah.
Okay, so
Hey guys. Thanks. Hey guys, it's Samantha time.
homework is partial fractions and then solving inequalities in one variable is homework 8. So should we just do homework 8?
Yeah, homework 8 is actually what it is. Right. Tell your friends. I guess we're doing them out of order. Oops. All right, doesn't matter.
Wait, so homework 8 tonight, homework 7 tomorrow?
Yeah, I guess so. It would be very confusing if you did the homework tonight. I know it's the wrong one. I forgot which order we did them in, so that's okay. One does not rely on the other, so you're okay. All right. I know that just caused pandemonium. Listen, we have a more complicated example to now show you. Matt is tired of polynomials. Yes. He says, give me something crazier.
Dang it, Matt.
All right. So what about this guy? And let me think critically with you again. I know, again, it's not just true for polynomials. It's true for any function. That if our function takes on the value 0, then it has an opportunity to switch sign from positive to negative or negative to positive. So even though it's not a polynomial, we still care about the
So how do you do
the zeros. Is there any time when this function is 0? How about x equals -1/2? Yes, or a, whatever it is. So it could change sign at -1/2, right?
Don't we all?
All right, let me hear from Eric here. Go ahead.
The function is also undefined x equals -3.
Okay, and is that useful to us?
When you're like the answer, because it means you can't set that.
Okay, that couldn't be in our answer. That's true.
Breaks your set sum.
We should mark it somehow.
Yeah, when you write your answer, if you say like that you have a set that goes.
All right, we'll make a note of that. That a can't possibly be -3 or 1. Do we need to include it on our number line though? What do you think?
Yes.
Well, let me ask you this: at a vertical asymptote, could a function change from being positive to negative, or negative to positive across that asymptote? The answer is yes. So I'm actually concerned about it not being defined. But I'm even more concerned about the fact that actually this function could change from being below to above the x-axis as we change over that as we go across that asymptote, right? And you know that's true for even the simplest case 1/x. 1/x goes from being below the x-axis to being above it, and it never crosses the x-axis. Mind blown, right? All right, so at a vertical asymptote, we need to be careful too. We're going to list any time we have a vertical asymptote as well on our number line. All right? And now we're going to do the same test. Are you ready? If you plug in a number like -5 or -5,000, either one, you'll get negative over a negative times a negative, right? What is that going to be over here? All right, so we got a negative. What about in here? How about plug in -2 maybe? Did you get a positive? How about plug in 0 maybe?
I'm tired, but it's a negative.
Is it a negative?
Yes.
Negative, so then.
And what about, how about if you plug in 5 million or something? All right, we're plugging a number bigger than 1 in, and again, we don't care about the y value, we just care, is the y value going to be positive or negative? Which is it?
Yes, you can use the union.
All right, so now we're asking, when is this function less than 0? When does this expression output a value less than 0? So now we can look at this picture we just drew that's so beautiful. Over there and in here, we're looking for strictly less than 0. How do you like that? So yeah, we can write from -infinity to -3 exclusive together with -0.5 to 1.
Oh, you. Oh, I did it all.
plug 0 in, you get 1 over 3 times negative 1. Is that okay? Yeah. Okay. Anything else you want to say about that example? I thought I saw another hand, but we're going kind of quick because we want to get to the really good stuff, right, Matt? Matt's in charge today. Huh?
Are you gonna have like rational function on one side of the inequality and then on the other side?
We then you have to combine them or something, right? Move them over, combine. How about we throw a square root into the mix? Doesn't that look like fun? All right, let's do it.
Well, it can't go past -1's the lowest, and it can't go to -1.
All right, we want to list our critical values again here. What are they? 0 and 4 and -1, I guess, huh? That's kind of interesting. So let's plug a number in like -5, something to the left of -1. What happens there?
Yeah, you can't do it.
You can't do it. So this is mathematical notation that has been passed on from generation to generation. Okay. I think it was Lebesgue who first pioneered the use of that symbol. Okay. It's from like an ancient, like a Latin alphabet, actually. I think that character.
I thought it was Italian. Like,
It's Italian, maybe? Is that what it is?
yeah,
Okay.
yeah, like
-1/2.
Luigi with the little-
How about -1/2? How did it come out? I got to think about this one. We got a negative squared and then a negative cubed over. This will be a positive. We're plugging in -1/2 or something.
So it's gonna be negative.
So it'll be negative?
Yeah.
All right, so I had to think about that one. What about at 0? I mean, what about at 2 or something in between 0 and 4?
Positive.
Plug it in and see, please.
No, negative.
I just am not so sure anymore.
Negative.
That'll be the same setup here, except that, right?
Negative and last one's positive.
So that's negative. And then the last one is positive, is that right? Because that'll be what it is. The last one's that.
So it's only from not
How do you like that
including
picture?
infinity.
Is this working for us? Okay. All right, with that in mind, we're looking for where is this greater than or equal to 0? All right, so I think it's definitely over here. Greater than 0. And also it's greater than or equal to 0, so we want to include 4. All right. Yay, let's make that as big. There we go. Perfect. And we're done, right? Yay, we're done. Right? We're done, right? Wait. Wait, what about what? What'd you say? What about 0? Doesn't 0 work? Oh yeah, and what about -1 too? Don't we want to put that on there? No.
Stop trying to trick me.
I'm trying to trick you. Okay, I think we're officially done now. All right, so we might write it this way. How about? All right, so y can be in this set or in this set. All right, so y.
Wait, but the y is really the x. That's so stupid. The y is really the x.
So yeah, 0 works. Singly, just 0, and then anything from 4 and beyond.
It's really y and y.
How do you like this? Yes, Peter. Peter, guys, it's Peter. It's Peter time, okay?
Peter Bard.
Peter B.
I was just going to ask, do you have to like write this squiggly lines?
I mean, you could write, maybe more informally, you could just write 0 and 4 to infinity, and maybe I'd accept that. If you want to be like cool and technically, mathematically savvy, you might write it the way I did, huh?
But I can't control it. Like,
It's good practice on your curly braces, I agree.
I'm so bad.
All right, do that one now. I don't mean this one to be too much weirder necessarily.
Okay, -2.5. And a point and negative 4. And a point at 0. Okay. Anything past negative 4 doesn't work. Frowning face. I'm gonna write the frowning face on this. Three on works, so that's positive.
Let me know if you get an
0 to 3 works. Negative 2 to 0 works also. All this what? But not 0. 0. 0 is negative. Well, 0 is not negative. 0 is not. Well, no, it's not asymptotic because it doesn't work. It doesn't work.
No, when 0 is asymptotic at 1.
Yeah. You get a frowning face. Okay, and negative 4 is also a frowning face. You can't include that. No, we didn't say rational. Negative 2, you just get 0, but that comes every time. From negative 4 to negative 6. Wait. That's negative. Negative 0. 2 is included. What are we doing?
Okay, so yeah, what are the signs going across here? From over here we have a happy frowning face. In here, negative. Okay. Positive. All right. Are you positive?
You're so funny.
I know. All right. So we want negative 2. All these values, right? And we're equal to 0, right? So we want them all.
I know, right?
All the way out, right? Does that look good?
No. 0 doesn't work.
All right, how'd you do? Come back.
I wrote 0.
All right, so something like this then is your answer. We got a punctured interval. Yeah. Yeah, you could just write negative 2 to infinity and also that z is not 0 or something like that. Yeah. All right, so I want to make sure you see the kinds of things you can get. We should give you a preview of tomorrow's warm up. That looks like fun, huh? Okay. Find the domains.
Wait, go back to
No. You gotta save something for
Wait, but
another day.
like horrible things. I guess you could simplify it out.
Maybe we'll give it to you on Monday or something.
I need to build this.
Yes.